So let's start. I'm Ariful Ambia from Walton High Tech Industries PLC. To get some attention, how many of you using Walton product? Any? Okay. Okay. Being a Bangladeshi company, always you are discounted. সব সময়ের জন্য ডিসকাউন্ট আছে সো জাস্ট আমাদের ওয়ালটন প্লাজা আছে ঠিক আছে যে কেউ গেলে ডিসকাউন্ট ছাড়া কেউ আমাদের প্রোডাক্ট কেনে না দ্যাট ইজ দ্য ওকে maybe we can do that in future because we are not prepared for that. My co-presenter also knows we did this presentation in maybe 1 day interval. We didn't get that much time to think of. In future, maybe we will also try to sponsor or something. Okay, that's good. Okay. So today's we will present something what we are doing in Walton. Using the underneath Kubernetes platform. So as you see the title, the role of a private data lake for sustainable business growth. So being a biggest electronic manufacturing company of Bangladesh, as you imagine, we have huge number of data. We have huge number of data, not big like the telco, but kind of in the middle, because we have a lot of outlets all over the country. Just to give you some perspective about the sizes, we have 700 our own outlets. We have the most outlet for the servicing center we said in the country. I'm not sure about the right now how many. Almost all the district we have service center. And so another perspective, we have easily 20,000 direct employee. And if we consider our direct and indirect people who is actually involved in business with Walton, our stakeholder, it is about 50 or something, 60 kind of thing. So huge number of people are involved with Walton electronics business. Beside our own outlet, all of our distributor who do business with us, they have our own apps to do business, sales, service, and everything. So imagine all of this data come to our data center, and we had to manage all the information all together. Some other perspective is that we had more than 10 million electronic user information, like as you are using our electronics devices like fridge, AC, and whatever. Most likely your phone number is lying in our database. So it is more than 10 million, I would say. 10 million people's information we have to manage. And if I consider the product, it is almost double. So 20 million products information attached with the 10 million, in average, 10 million people's information we have to manage just to make sure that we are able to give you the after-sale services. Because it's a big promise from the Walton that we give after-sale services to our customer, which we actually, we think we are pioneer on that. giving the services to the people on time and the way we want to do. So this is a few perspective why actually we take it very seriously, this sustainable business growth. Okay, so without having a good functional data lake and this highly scalable, on the highly scalable system, we would not be able to do that actually. So it's not that much clear. So nothing fancy here. Actually, we did typical data crunching thing in data lake and data warehouse. We have data engineers, we have data analytics and data science team as well. So those are pretty standard, right? You can see that all are doing here we on top of the Kubernetes. And I should mention here Klovercloud here as well, because they are the enabler for us, because we are not the in the area of Kubernetes. We only enlightened by Klovercloud, and it was 2 years back, I think. 2 years back. I think more than 2 years back. Almost 3 years, yeah. 3 years back. At that time, we had a meeting. I can recall this thing. We had a meeting on that, and they told us how the solution should be, and so we are doing that. So all that data infrastructure, ETL, processing, mining, data warehousing, data lake house, all of the points we touch in our solution. And today, from my part, maybe I would more focus on the analytical part. I'm a data guy actually. I'm not a tech guy anymore. I was there, but I'm not now. I'm a data guy, so I understand the data very well. I believe I do. And for the technology support, I will ask Toha Mr. Toha to give me a hand. Oh, sorry. So this is the solution. If you can come and explain a little bit. This is his part actually.
So from here, I'm Toha Khan. I'm from Klovercloud. And actually, I'm going to give a brief overview of this later in my part. So for this section, I'm just going to brief you for now. So here actually, data from various sources. We are collecting the data using a scheduler, and you can generate the scheduler using any Airflow or anything else. And from that, we are dumping those data in S3 and presenting that data using Iceberg open table format. And then Ambia Vice team use ClickHouse, Trino, Superset, etc. for their analytics team.
Thank you. So maybe I can try give you something more like that. So if you see Spark, we are using Spark extensively. So this is one of the enablement we did. From my side also, my team enjoyed this Spark and PySpark, the capacity of the distributed system very much. I can explain. I love it very, very well actually. So because before that, our OLTP system runs on Oracle. We are one of the early adopter of the Oracle e-business suite as well. If you know the Oracle things, so they are in the OLTP. So OLTP system comes with its own capacity. It is good for OLTP, and good for the business to run the financial system and sales and everything very well, no doubt about it. But as it is OLTP, it is lack of this kind of batch processing, which we need heavily for the analytics and machine learning thing, and all the kind of reports on it. So when we were trying to doing all those things in the OLTP, definitely it failed. It failed in a large scale. So then we use the Spark. On top of the Spark, we run mostly PySpark, most of the case. And we are using for the distributed database Trino. Here you can see Trino thing, just in the middle of the right side. So most of the data the analytics team, they do work in the Trino. Then the ClickHouse we have for the presentation thing, and in the bottom we have Superset, and also in the up Kubeflow. So we are also using machine learning heavily, and really it works like magic in some cases. I will try to give you some of the example of what we did with the all the machine learning capability that runs on Kubernetes and Spark. So this already I maybe mentioned. So I think we all know this OLTP and OLAP. I'm not going to explain it anymore. So for the Walton, actually we learn it from the hard way actually. So we should only use OLTP where it is meant to be the system, the Oracle system or Microsoft SQL Server, whatever it is, all the OLTP database. Should not use the like machine learning and heavy load analytics in OLTP. We should use the OLAP thing. So from Walton perspective, we learn it very hard way. So this is one of the elaboration why you should not use OLTP database for all kind of workload. So this is one of the comparison between OLTP and OLAP. So there are some of the advantages we are giving is maximizing the data integrity. I will not go in detail. So let's jump into the cost, maximizing the cost benefit. Whenever you switch your load to OLAP, and if you do it properly and with all the, what happened that most of the time people don't want to change. What happened that existing IT, they don't want to switch to the OLAP because it is a big take. There is a learning curve as well. So if everything works properly and if every body of your IT system take this OLAP thing in a right way, I would say there must be a big jump in the maximization of your minimization of your cost and maximization of your use. It happened to be, it must be happen. Same thing happened to us actually. So few basic analysis I can tell you, kind of our story, how we, what we are doing and how we get benefit out of it. So we have a lot of analytical dashboard. So imagine that you have a very, very highly efficient and highly data crunching analytical dashboard. Everybody is seeing that every day, but that is not increasing your workload in your OLTP server. This is very typical in Bangladesh. Actually, if you see this kind of who are running or ERP, SAP, or Oracle, when people runs the very high-level analytical dashboard, their OLTP system get affected all the time. We've seen over and over this kind of situation. But in our system, I don't have to think about that anymore, because I separate my OLTP.
Hello. Hello.
Hello. So I will not go in detail of each of the analytical works. This is the dashboard. So we have lot of dashboard in such in our system. So few of them are market size analysis. As I said, consumer profiling and tracking. This is very important. We can tell from our system who is most likely going to buy his next deep freeze, because he already has a freeze. You got my point? Maybe some of you are already thinking before the Kurban Eid to buy a deep freeze, right? Not that much tough to think actually, if you think about it. So we can tell in advance, maybe in a week, who is going to show up in our showroom and see some electronic product to buy. How good is that? So definitely company will love it when we can show that kind of capability. So how we do that? Yeah, it's a big journey actually. There are a lot of components. Apart from the also Kubernetes, there are so many other components that we have to come up and we have to fix in our solutioning to find this kind of capacity. So this is the consumer profiling and tracking. We have BP, business promoter analytical dashboard. We can track all the business promoter who is working on this different outlet. We have very good district-wise market share analytics and also the competitor analysis. Even we have data for our competitor. Okay, so all we can analyze using our data lake and data warehouse solutioning. And easily we can do customer segmentation, model-wise popularity. Imagine we know, just take giving a perspective actually. This is one of the story that business, actually this is one of the question our business ask to our data science team, that if you see our product, there are a lot of colors, you know? There are a lot of ugly color as well, isn't it? Very red, maroon, and weird flowers. Those are very common, right? So how you feel as a customer? Even our business also thought that is it good thing to give all those colors and flower thing in Dhaka city, even in Gulshan? Most of us thought no. But our data science team find out this is negative. Why? In other contrast, if I tell you the story, we have also very good looking fridge, double door, big fridge. Everybody may think only these Gulshan people buy all those big fridge. Our data says no. Most of the big fridges buy in Mirpur area. You got my point? And same way we found that in Dhaka city as well, let alone the other part of the country, there is no pattern. Every color, almost every design sold equally. Then we thought, why this result come up? What is the reasoning? So then we come up with the theory that actually in Dhaka city, there is no posh area. You cannot tell like there is a, in Florida or something, there is a big area, only the superstar lives there. I forget the name. Only the superstar lives there, big mansion and everything. Actually in Dhaka city, we don't have. In Gulshan, if it is the poshest area of the Dhaka city, still it has a mixed kind of people is living here. This is our take. This is our take from our side. So that showing this result, we actually given the actually give the result to the management that no, we don't have to segregate our product line or this color variations and give some color to this posh area or Gulshan area and don't give other color to other side of the country. We are not going to do that. This is one of the way we actually using the power of data analytics, which is again powered by the Kubernetes thing. Without distributed system, we cannot actually able to process these millions and billions of data. We have more than 300 this kind of pattern, color and the flower designs, more than 300. And imagine so many combination, permutation and combination along the demography of the country. So if we want to do that kind of big analytics, actually we use some kind of machine learning over there and data science techniques. Definitely you need a distributed system, otherwise you cannot do. So last thing is demographic penetration. Same thing actually. So all are linked together. We understand what is the penetration down to the Upazila level. Can you imagine? Down to the Upazila level, we can tell how many cells can be generated. That much of capacity we have. And good thing from the government actually did, we Bureau of Statistics, they are gradually doing better and better actually. So last census done by 2022, published in 2023, this is very good, and we are utilizing all those good things of government. So ML, kind of few ML, so fraud detection algorithm, that alone, fraud detection and inactive mobile number detection model, these two alone actually save crores of taka. These two model alone save crores of taka. I will tell you in detail. Let's talk me about the inactive mobile number detection model. So this is open source, right? This one, if I will try to give you. This is open source. You can get this model in what it's called, Hugging Face. We open source this model. What it does actually, without any help of the mobile operator, we have Grameen, we have Airtel, all the mobile operators. Without having any help of the mobile operator, if you give this model a mobile number, it will give you a probability value, which tells you how much chance you have this mobile number is active or not. Sound complicated? I'm telling again. You will give a mobile number to that model. It will give you a probability. And what it will indicate, how likely this mobile number is active or not. So think about, this is just a model and it is open source and you can download it. And it gives a fairly good result, very fairly good result, actually say, and without checking the mobile number with the operator. We heavily use it because in our setup we had to, and I believe a lot of people need that kind of model, at least for the data pre-processing and data QC kind of thing. So this alone actually save a lot of our time. How? Otherwise, I had to call that person. I had to, my data center, we have the service center, right? Customer care center. What they do actually, they call the people who is using our product. They have to talk with them, is there any problem, or AC is working or not, because in the summer season, you know that a lot of people buy AC, wait for 2-3 weeks, a week to come this installation people to come and fix it. We have to make sure that people are happy and using the product. So we had to do lot of our call center. So otherwise, if we don't have that kind of model, they would end up calling lot of junk mobile number, and that happens actually. A lot of time people gives wrong mobile number intentionally or unintentionally. There are so many cases like that. So these two, same thing is the fraud detection analysis, because for each sale we give a good hefty amount to the seller and the customer. If you are aware of that, actually we have a digital campaign thing. It is already running, so we are giving 10 lakhs taka for the first winner. Almost already 32 or 35% already got 10 lakhs taka so far. Not this season, some other season as well. So for each sale, we also compensate 300 taka default. That means if you go to okay, so if you go to buy a product, maybe you will get 300 taka to up to 10 lakh taka. So going to giving that, we get lot of junk mobile number. So we had to give this fraud detection thing, and this alone actually saved crores of taka from Walton pocket. So I will close the session very quickly. So this way, we have lot of analysis which is actually contributed by runs on Kubernetes. So thank you.
Okay, so thank you, Ambia bhai. That was a wonderful presentation on the business side. So I'm back again. I'm Toha Khan from Klovercloud, and I'm going to talk about data lake solution on Kubernetes architecture and its technologies. So let's talk about the data lake challenges first. So the first thing we have to consider is the scalability. So after our data lake's initial deployment, it goes through several stages. So we have to make sure that our data lake architecture grows or scales accordingly. So adapting a data lake architecture that is flexible and highly scalable and that can process large scale data on batch and streaming. So next we have to consider what type of data we're storing in our data lake, in which format or who has access to it. If we don't consider these things, our data lake can become a data swarm very fast. And it can be very complex. So I'm going to fast forward this because we don't have a lot of time. So we have to think of a mechanism to finding data from that data lake without wasting additional resources. And then there is the cost factor, because almost all the cloud providers give services like ETL services, data pipeline services, which can be very expensive compared to owning your own private data lake. And also, there is the vendor lock-in issue. You don't want to get stuck with a single vendor. So here is an overview of data lake architecture, which is running on Kubernetes. So data from various sources. We are extracting those data using Airflow scheduler. It can be any external source or for any relational database or from other sources. And we are dumping those data on Amazon S3. Now we are distributing that data pipeline workload using Apache Spark ETL engine. Also, we can take streaming data or real-time data using Kafka queue, goes with the same Spark ETL engine, and dump those data on S3. So we are using a scheduler here because we don't want to hamper the actual transaction of those source databases. And we want to do the extraction in a later period of time. So data pipelines will run in a later period of time where the actual transactions are not being carried out. Then after dumping those data on S3, we have to have a way to represent those data easily. So we are using Iceberg here. So what Iceberg will do, that those data files in your S3, it will represent those data files as a table format for easy query, and it supports lots of processing tools, like it supports Trino, ClickHouse, as Ambia has already mentioned those. So I'm going to skip this for now. So let's talk about the first core component, which is Apache Airflow. It's actually an open source. It's an open source orchestrator for complex computational workflows and data pipelines. So it has several components, like it has its own web server, its own web UI, it has its own executors, DAGs. So the main component I'm going to talk about is the DAGs here, because in the DAGs, it actually means directly acyclic graphs. You mentioned the dependencies of your tasks, data pipelines, and other things in the DAGs section. And then the rest is the hooks operators. With hooks, you can mention the connections of like your S3 buckets or any other database services. So we are using Airflow here because it's highly modular and highly scalable. It can scale up to infinity given the proper resources. It's able to generate dynamic data pipelines with very easily. So let's see how Airflow works on Kubernetes. So after a user has written a DAG for the Airflow, it will submit to the web server. And the metadata of that DAG will be stored on the database, which is running on a pod. You can use any database like Postgres or MySQL that is supported by Airflow. And a scheduler will be running on Kubernetes as a separate pod. And in that pod, there will be the executor pod. So we are using here Kubernetes executor. Airflow supports lots of executors, like it has local executor, sequential executor, or celer executor. So what will Kubernetes executor do from the scheduler pod, that it will just need the access to the Kubernetes APIs to orchestrate those data pipeline tasks being carried out on separate pods. So once the scheduler detects that the DAG is ready to run, it will pull that DAG's information from the DAG directory, and Kubernetes executor will request the Kubernetes APIs to schedule those tasks on separate Airflow pods. And after the task is being finished, it will update the result on the metadata database, and whether it's successful or whether it's failed. And then they will automatically be terminated or scaled down without wasting any more resources. Next, we are using Apache Spark, which is a ETL analytics engine for large-scale data processing. We are actually distributing the workloads with Apache Spark here. And there are various reasons for using Apache Spark, but one of them is it's cloud agnostic. You can deploy it almost in any cluster, and it's highly efficient in resource allocation. So when a user Spark submits their application on Kubernetes, it will start a Spark driver pod, and Kubernetes will request for the executor pods to the driver pod and schedule those executor pods. And when the driver pod has connected to those Spark executor pods, it will carry out those tasks on those executor pods. So after the task has been carried out in the Spark executor pods, they'll automatically scale down, but the Spark driver pod will keep on running. So you will have to manually terminate it, or Kubernetes can garbage collect it, or have any other mechanism to automatically delete it. So there are various benefits to run Apache Spark jobs from the Airflow, mostly because you're having the scheduling and the job monitoring from the Airflow UI. You can retry your failed Spark tasks using the UI. And you can write dependencies of a Spark task. Like if you have, you can have separate Spark application on different DAGs without manually intervening each time, and they can run dynamically. And also, DAG will ensure that the Spark tasks are being only carried out after the preceding tasks are being completed, like for like data ingestion or any other things. And it's very scalable. Airflow can handle lots of Spark jobs with ease. So combining these three, Apache Spark, Airflow, and Kubernetes, can be very lucrative when developing a data lake. So let's see how these three comes to play together. So when Airflow Spark submits an application, it will go through the same process. It will start the driver pod, carry out the task on the executor pods on different nodes, and Airflow will update the result on the database. Data scientists can directly submit their Spark application using Jupyter notebooks or any other script or any other scheduler like Airflow. So here is an overview of a DAG graph from Airflow UI that is running a Spark job. So as you can see, those blocks represent each task which are mentioned in the DAG. And after the preceding tasks are being completed, the Spark submit task will carry out. If any of the tasks fail before, then it will stop right there and mark it as failed. The next thing is that we are using Iceberg, which is an open table format, to represent data from our S3 data files as open table format. It was actually developed by Netflix to process a large data set at a scale. It offers highly flexible SQL that can support lots of petabytes of data. So table format is a way to tell what type and change schema of Iceberg tables very easily. You can add columns, you can remove columns, change any data type of a column. And then there is the data versioning part. Iceberg takes lots of snapshots, so you can time travel and change any data. You can roll back any table to a particular good state. And it supports lots of processing tools like Apache Spark, Rhino, ClickHouse, Kubeflow for machine learning models, and many more. So that's all from me. Thank you.
Sorry, apologize. We already running out of time. আমাদের আরো অনেকগুলো সেশনস আছে আফটার লাঞ্চ। সো যারা লাঞ্চ করেননি লেভেল 4 এ শুরুসি রেস্টুরেন্ট আছে, ওখানে লাঞ্চ করবেন এবং লাঞ্চ করার পরে অ্যাজ সুন অ্যাজ পসিবল ব্যাক করবেন আমাদের প্রোগ্রামগুলো। আর যাদের আছে টেলিমেট্রিস, ওপেন টেলিমেট্রি ট্রেসিংয়ের উপর ওয়ার্কশপ আছে, প্লাস হচ্ছে মাল্টি ক্লাস্টার মনিটরিং, তারা লেভেল 3-তে ওয়ার্কশপ 1 ওয়ার্কশপ 2-তে চলে যাবেন। I would like to request Ambia bhai, please come once again in a stage spot, take a crest, and Toha bhai is here.